Okay, so in this video we're going to start making a visual application. Be quite a simple one, just a couple of gauges, one for speed, one for revs. We'll be getting the information eventually from the car's canbus, but to make it easy so that everyone can follow along without having to set up a test rig with a canbus and multiple Raspberry Pis, we're going to be using virtual canbuses. So I've already done a sample app that I'll bring up here, so we'll show you the end goal. Might look a bit different, we'll probably add some styling to it and some other bits, but this is the basis of it. So if I start up the simulator for the car to simulate the canbus signals that you normally get, you can see here how the gauges are mimicking, similar to what a car would do. And this is what we'll be building. It'll be, so the values the gauges are showing, that's reading from the canbus, and we've got a reset button here which will reset it back down. So at the moment it's mimicking a car limited at 155 mile an hour. See the rev gauge is bouncing. If we click reset, puts them all back to 0, which that is simulating right into the canbus. So it's all done from a web interface. We'll be using nodeJs to write it, and there's a nice package called Electron which allows you to turn this web page into a full functioning app. This is pretty much the exact same setup that I use for the apps I've got running. So we'll go through all of that. This is kind of the layout we'll be going for. It's pretty simple. I haven't got very good paint skills, so we'll have the car with the canbus connected to the Raspberry Pi hat. I'm not using the Pi cans anymore. I've still got a couple and I'll still use them, but I found these WaveShare ones which are pretty much a third of the price for the same features, and well, to be honest, it's better features. Like this is the canbus FD one, so that it's got 2 CAN channels, it's got a 12 volt inputs, so they're pretty good. I'll probably go over these in another video, but it doesn't matter what you use, whether it's a Pi can or a can hat, as long as it's got the canbus signals. So what we'll be using on the back end, we'll be using nodeJs as the main language, main software. We'll be installing some packages, so there'll be socketcan, Express, socket.io for real-time communication. Express is just a web server app, so kind of like Apache from a few years back. You can get a web server set up with this in seconds, and it all runs in the same script as everything else we'll be doing. So the front end will just be using standard HTML and JavaScript, but also socket.io to get the information from the back end in real time. So the first thing we need to do is sort of set up our development environment. Because socketcan's a native nodeJS package, we can't really develop it on the Windows machine or the Mac because it needs access to the Linux kernel, so it kind of makes it a pain if you're trying to develop it. So you can either download an IDE on the Pi and program in there, or what we're going to be doing is setting up a Windows SMB share, so we can actually edit on the Windows PC, and it'll be editing the files on the Pi. Then we'll just be flicking back to the remote desktop to run the programs that we'll be making. So to do that, the first thing we need to do is install SMB on the Raspberry Pi. So to do that, we'll do a sudo apt install, and then a samba, and also samba -common -bin, and press enter. So I'll be putting all the commands on the web page I've got with a little text write up so people can follow along, so don't worry too much about trying to copy them down as I type them. You might get a pop-up when you install this the first time asking whether you want to use, I think it's a DNS service or something. Just say yes to that if you get a pop-up. Okay, so now we want to make a directory where we're going to host the file. So if we type in mkdir, we'll do it in /home/pi/shared, then just press enter on that. I've already done it, so I'll just control C down, and then we've just got to make an adjustment to the Samba config. So to do that, we'll do sudo nano /etc/samba/smb.conf. It should open this file up. So if you scroll to the very bottom, I've already added this in, but again it will be on the web page if you want to just copy it off. But it's just this, so you just give it the folder name that you want to share, and then you just set up all these options exactly as they are here. So I'll put it on the web page. You can just copy it straight out, paste it in, then Control X to quit, and then if you made a change, you've then got to press Y and then press enter to save those changes. So the next step is to make a user. So from the Windows machine, it'll be the user that you log into the Pi with. So to do that, you do sudo smb passwd space -a and then the username, which is Pi. So again, I've done this already, but you'd press enter, then it'd ask you for the password, then just type in the password that you're going to use from your Windows machine. So once that's done, just to test it, if you open up your My Computer, click on your network, up here if you type in / twice, then the IP address of the Pi, so mine's 192.168.0.85, / and then it'll come up with the folders, and then you can just click Pi share, which is the one we just made. So we go back up one directory, right click the Pi share, then you should be able to map the network drive. So we'll give it the drive of Z, and then leave the other options. Click finish. Now we've got down here the drive of Z. So it's fairly straightforward. There's other examples online if you run into any issues. So back on the Pi now, we need to change to that directory we just made. So cd /home/pi/share. So we're now in this folder. So let's make a project directory. We'll say mkdir, and we'll call it tutorial. Now hopefully on the Windows machine, inside here, yeah, we've now got the tutorial folder. So let's change into that folder. Now we need to tell nodeJs that this is our project folder where we can start installing packages. So to do that, we type in npm init, which initializes that folder as a node folder, and it will run through and it will ask some questions. For now, we'll just leave them all blank. If you want to find out more about Node, like the whole Node package manager is pretty complex. There's plenty of stuff online. It's one of the most popular languages at the moment, so there's tons of stuff you can find out from online. So by doing that, we've now got a new file in our folder called package.json. So on the Windows machine now, we can open up that folder in the editor that you want to use. I'm using Visual Studio Code. So we can just go open folder, this PC, tutorial, and then just open the folder as a whole. So now you can see in here we've now got that file. It's just got the answers to all those questions we put in. As we install packages, they're going to appear down here as dependencies. So if someone else wants to use your package, all they've got to run is npm install. Then it will download everything that you've used to create that app. So with that, let's install our first packages. So for people who don't know about npm. I'll just do a quick overview. It's a node package manager, and there's tons of stuff on here that people make. So people make packages and then you can use them within your project. So similar to pip for Python, it's just a lot more modern and a lot more user friendly. So if we wanted some gauges, we could type in here gauges, and then there's a ton of gauges that people have made. These are the ones we'll be using in our project later on. They're the ones that are on this web page. So the first one we want to install is one called socketcan, which allows nodeJs to talk to the canbus. And this is the one that's the native one. So some examples, there's links to the GitHub where there's all sorts of documentation. So to install it, we need to do npm install socketcan. Then it will run through, it will download the packages and then install them. Okay, so with that now installed, if we open up your IDE again, you can now see that dependencies that I said about earlier, and then the package that we've just installed. So we've installed socketcan, we've installed it at version 2.6.0. So as we install more packages, this will fill out. So the next thing we need to do is set up our virtual canbus that we're going to be using. So to do that, there's 3 commands we've got to run through. So the first one is sudo modprobe vcan, press enter. The next one is then sudo ip space link add tev for device vcan 0 type vcan. I've already done this, so I won't press enter, but normally you'd press enter on that. And then the last command is sudo ip link set up vcan 0. Once you set them up, you'll have your virtual canbus up, which if you type in ifconfig, it'll appear here as vcan. So the first program we're going to write is the simulator for the car. So all this is going to be doing is sending out canbus signals that we'll use. So it's going to be quite simple. We're just going to be sending out revs and speed. We'll be sending them in the same package, so in the same ID, in the same array. We'll be sending them all as one. So we'll be doing this from Visual Studio Code now. That's where we'll be writing the code, and then we'll just be switching to the Pi to run it. So first thing we need to do is make the file. So let's do that. We'll just call it, keep it simple, call it car.js for JavaScript. Let's make this window a bit bigger. So the first thing we need to do is import the module that we just installed. So for that we type var for variable, give it a name of can, and then we'll say it's equal to, and instead of, I imagine most people probably use Python the most, so instead of like import time, what we do is type require, then we put in the name of the module we want. So this one's socketcan. Again, it's already starting to fill it in. So now we've imported that module. So now we can do var. We now need to make a channel. So variable, and we type in channel is equal to can, which we set up here. Can dot, and then it's prompting us with the functions that can has. So you want to create a raw channel. You can see here it tells you the options, so channel with a string, timestamps, protocol. So we'll call this one vcan 0, which is what we set up when we set up the virtual canbus, and then we'll just give it the value of true there. I can't remember what the true is, but it's always in there. Okay, so now we've got this, we've got access to our channel. The final thing we need to do to make the channel work is we need to do channel dot start, and that starts the channel. So I always leave that at the bottom. So if you think what we're going to be sending out is we're going to be sending speed and revs, and we also need an ID. So what I always do is I create a message, so MSG, we make it equal to an object. So for the object we need to give it an ID, which is the can ID that it'll be sending on. So we'll call it 500. Then we need to add another key and value to the object, so we do a comma, and then this one we'll call data, and we'll make this equal to an array. So this is where we get our 8 bytes from. So when you're working on the CAN bus, you're receiving 8 bytes all the time, or sending 8 bytes. So we'll just make this an empty 8 bytes for now. I don't know. 1, 2, 3, 4. Yeah, so that's our 8 bytes all set to 0. Okay, so we'll keep it nice and simple at first. We'll repeatedly send our empty message. Just make sure that we can get it. So to do that, to send things in a constant loop, like every 100 milliseconds we're going to send this, you use a nodeJs function called setInterval. And with that we'll use, so there's multiple types of functions in nodeJs for writing. There's arrow functions, or there's the old style of doing functions. For this we're going to use what's called an arrow function, which that's how you do it. So if you're passing parameters in like you would in Python, you'd put them inside these brackets, and then you got the arrow, and then the code goes inside the curly braces. So let's just keep it nice and simple for now. If we make a new message here, so similar to what we've done up there, we'll just call it var out for the output message, create it as an object, and then we'll do the out.id is equal to msg.id. Then we also need the data, so the data is a bit different. So the data, when you're sending it out, it needs to be what's called a buffer. So it's where it converts these integers into like the hex values, and it will send them out. So to do that we'll do out.id, out.data, sorry, is equal to new, and then buffer, a capital B. Let's change it to array buffer, which we don't want. New buffer, and then we'll put in msg.data, and then here finally, so we built our new message with the ID and the buffer. So finally we just want to send that message out. So to do that we just do channel dot send, and then we just pass in the object we made, so that out, and then that should now send the message. To set the frequency that we want to run this function at, in between the curly braces here and the brackets we just put a comma, and then in milliseconds we say how frequently we want to send that out. So let's do 100 milliseconds. So if we save that, we'll now run that. So I'm kind of doing this on the fly, so no doubt we'll come into things that don't work, and we can just work through them. I think it's the better way to do it. So to run it, if you go back to your Pi, and we're in the tutorial folder, you see we've got a file called car.js, which is the one we've just been programming. So let's type in node, which is the same as when you're doing Python. You normally type Python and then the Python file.py. So we'll do node car.js. And now that's sending it. So in this terminal, if we imagine this is the car that we've just started up, so in this one we can now do a candump. So candump vcan 0. You can now see that message that we're sending out, we're now receiving it like you would from your car. So really what we've done is a very basic emulator for a CAN bus module in your car. So just to just to check it, if we go back in here and we'll give this a value here of 255, which in hex is FF. If we now stop our simulator, restart it, we can now see we're now sending FFF instead. So we've verified that's working. So the next bit we need to do is kind of set up our revs and our speed. So let's create separate variables for both. So we've got var for variable, speed. We want it to start off when the program first runs on 0. We want to do the same for revs. Okay. So if you think about this, what we want to do in this interval, so we're running this every 100 milliseconds to create the same effect as what I showed you with the example that I've already done. We want to add values to the speed and to the revs every 100 milliseconds, or however frequently you want to run it. So before we get into doing it in the canbus, because we've got to turn it into a buffer and an array, let's just do some simple examples. So in Python you use the print a lot for fault finding and debugging. In nodeJs it's called console.log, like that, and then this will just print it to the terminal. So just as a test, let's do console.log, and then we'll just say running interval. Now if we save that and then we restart this, you can now see every 100 milliseconds it's printing to the terminal running interval. So we could go one further, we could say let's console.log speed is colon, and then we can just click plus and type the speed in. Then we'll do the same, we'll say revs are, and then that's revs. Yeah, now we're getting it through here. So now what we want to do is increment this. So we want to increment it every time we run that loop. So let's say, do it above. So let's say speed is equal to speed plus 100. Oh no, not 100, plus 2 plus 2. Revs is equal to revs plus 100. So now we run that. You can see they're increasing. So you've got revs increasing and we've got speed increasing. So the scales are off and it will just constantly keep going. So first let's adjust the scales. So back in here I've already experimented with the demo that I've done. So I know speed is equal to speed plus 1 works nicely with revs is equal to revs plus 240. So if we run it again now, you see they're going up quite nicely together. Obviously we want to put a limit on the revs and we want to make it simulate a gear change where the revs drop back down. So that's fairly simple to do. So for that, if we just type in if, so similar to how you would with Python, in this you got to put the expression that you're checking in brackets. So we'll say if revs are greater than 7,000, it's a pretty standard rev limiter. And then after the brackets you then do the curly braces again. This is what you want to run. If this expression is true, you want to run what's in the curly brackets. So we'll say revs are then equal to 1,000. So if it's greater than 700, we'll set the revs back down to 7,000. Pretty simple. Now running it, we'll see it get up to 7,000 and it's dropped back down to 1,000, and it will just keep looping through. Obviously this is going to keep going and going, so we kind of want to set a limit on the speed as well. So let's say the car's limited to 155 miles an hour, which is pretty standard for what cars come out of the factory with. up here, let's do similar again. Do another if. So we say if speed is greater than 155, we'll set speed equal to 155. So it will never increase over 155. So running it now. See it reach 155 and the speed stopped, but we can see the revs are still going, which is obviously not what we want. So we need to stop that. So when it reaches 155, we also need to stop the revs from increasing. So really, if you think about it, it's pretty easy to do. Okay, so we can kind of refactor this to make this all work a bit nicer. So if we now change this to, instead of if speed is greater than 155, let's say if speed is less than 155, and then we'll move this addition inside this. So it's just, to me, it's a bit of a cleaner way of doing it. So if speed is less than 155, then you do speed is equal to speed plus 1. And what we can also do is add the revs into here then. So now when we reach 155, both the speed and the revs will both stop increasing, which is what we want. So let's save that and we'll double check everything's still working. So it looks to be going up the same. Then when it reaches 155, speed stopped and the rev stopped, which is perfect. So the next thing we kind of want to do, just for some aesthetics really, we want to make the rev gauge kind of bounce, like you see in the films, you know, when someone's reaching the limit and the rev gauge is bouncing up and down. So let's do that. So if we leave it outside of here, so you think we only want to bounce when we're reaching 155. So let's do an else. So here we're saying if the speed's less than 155, we run this. We can say else, then the curly brackets. So this now means the speed is greater than 155. So equal, you know, the speed is 155. We can now, on one cycle, we can add 100 to the revs, and then on the next cycle we'll remove 100 from the revs and it'll give it that nice bouncing effect. So to do that we need to add an extra variable in. We'll just call it up, and we'll set it on the first cycle, we'll set up equal to true. Putting it here is wrong, but we'll show that in a sec, and then we'll change it so that it works right. So inside this else we can add a nested if statement. So if up, when you type just the value in here, it's basically checking a boolean to see if it's true, so it defaults to true. We could write if up is equal to true, but we can keep it nice and simple and just say if up's true, then we'll say revs are equal to revs plus 100, else. So this means if up is not true, say revs are equal to revs minus 100. So it gives us that nice bouncing effect. We also need to change the value of up. So if you think if up is true, we add the revs to it, and then we want to say up is equal to false, and the opposite down here, up is equal to true. So what this should do is create a nice bouncing effect on the revs. Where we've put it is not quite going to work, but let's test it. You can see there, we've got to 155, but the revs are still increasing by 100 each time. So you can probably try and figure this out yourself if you want, or we'll just go through it now. But if you want to try and figure it out yourself, pause it, try and do it. But what's happening is, because this interval is running every 100 milliseconds, each time it runs at the start, you're setting up to true. So it's never going to be false. Even though you're setting it to false here, when the cycle next runs, because up is equal to true as at the top, it's always going to be true when it gets to the point down here. So all we've got to do is cut that out, paste that up there, save it, and then we'll give it another test. There you go, it's working perfect. So you see it's flickering between 6040 and 6140, which is giving us the perfect bouncing effect. So this little function now is working how we want it to work. We've got our speed and we've got our revs. Now we need to send this out every 100 milliseconds in the canbus. So if you look at this up here, this is where we need to put our values in. Now obviously each one of these is just a byte, so each one of these, their maximum value is 255. So for speed it would be fine putting it into 1 byte, but for revs it needs to cover more than 1 byte. So to do that, we need to turn our revs value into an array of bytes. So what we need to do from the start, if we go var, we'll create a new variable and we'll create an empty buffer. Rather than converting this to a buffer, which is what we're doing down here, we'll make an empty buffer. To do that, create your variable and then you say is equal to buffer dot allocate, so just the shorthand for it, and then you say how many bytes you want to allocate to the buffer. So we want to allocate 8 bytes to that buffer. What we're going to do is we're going to set the first 4 bytes to be the revs, and then we'll set the next 2 bytes to be the speed, just in case you've got a car that can go over 255 miles an hour. So we create the empty buffer. Now we need to write our values into that buffer. So to do that, let's delete this out for now, because we don't need that. We now do, once we've set the values to what we need to do, which is done in this section, we now do buff, which is the variable we made up there, buff.write, and we're going to be writing an unsigned integer set as a big endian. So to do that, you do write capital U I N T for integer, unsigned integer, be, and then here you write in first the value you're putting in, so it's going to be revs, and then you write in the byte you want to start writing it in from, so you want to write it in from 0, and then the length of how much you want to write, so we want to write 4 bytes. And then we'll do the same down here for speed, so we'll say buff dot write unsigned integer, big endian again, speed, comma. Now we want to start at byte number 4 because we're writing 4 bytes in for the revs. Remember they start from 0, so it goes 0, 1, 2, 3, that's our 4 bytes. We want to start writing from byte 4 and we want to go for a length of 2 bytes. So start from 4, length of 2. And to check what we've done's right, we can just do a console.log buff. So we'll see the value of the buffer after we've written to it. So save that, come back in, and we'll start this back up. And we can see now, it's looking a bit more like a canbus message now. You see the values changing. We're not sending it on the CAN bus yet, so we can't do the CAN sniffer, but this is just giving you an example of what that buffer's looking like. We see the revs here are flickering between 100. So we're almost there now. All we've now got to do is send this buffer out over the CAN bus. So at the moment we're still creating a new buffer and we're putting this array into that buffer. So instead of that, we just want to do out.data is now equal to buff. We don't need to create a buffer because we've already created the variable of buff as a buffer. So we just need to set it there. So if we now save this, if everything's worked, we'll start it back up. We can now see in our candump, we can now see our can messages are formatted correctly. So instead of a candump, let's do a can sniffer vcan because we're using the virtual can. We can see our message there. Doesn't seem to be keeping up with the speed that we're sending it at. It is saying it's changing, but it's staying as FC. I think that's because we're flicking between 98 and FC so quick it's not picking it up. Let's just check it. Let's change the frequency of the message to, change it to half a second. Should be able to see it then. There you go, and we can see it going up. So really now we've successfully created our car simulator for what we're doing. It's quite simple, it's just speed and revs, but it'll give us something that we can then use to create the front end of the project. So in the next video we'll create the web server, which will be reading the CAN bus the same as the CAN sniffer is, and then it will be sending those values out to a front end, to a visual front end.